Okay, make sure that your mics are on. They are not muted.
Professor can't.
Okay.
Someone has the microphones on. Please turn all your the microphones off of your computers, except the presenters. Thank you.
Good morning, ladies and gentlemen, fellow students, faculty members, and advisors. Today we present to you the Bliss wrist. Maintain your emotional frame.
So here we'll be talking about our outline, where we introduce the team members, project motivation, project description, related theory, and as well as software demos. Testing iteration, project completion, software demos, our costs, code standards and constraints, and things that we learned throughout this process.
Hi guys, my name is Chase, and my work was focused more towards software and research.
Level 3, I was working towards software and electronic research.
My name is Caesar. I work in database management, and I also developed the web page for our main portal.
My name is Daniel Mouillet. I am the project leader of Bliss wrist. I helped with the hardware side as well. Now, moving on from our introductions into our motivation, our client has come up to us and asked, how do I keep my emotions under control, specifically with anger? And most of the devices we saw on the market work in a more private setting, dealing with more of a meditation aspect, or just a way to tell when you're angry based off physical attributes, but not dealing with the actual problem. And what we wanted to do was something that'll actually help the person calm down. And we honestly believe that the people that would benefit from this would be anger management patients, psychologists, and psychiatrists due to their line of work or the side effects that they suffer from anger.
So essentially the impact of this device is that I can monitor your mental health through accurate sensor readings listed below, and it can help provide helpful feedback for you. Since then, we also added a muscle sensor, EMG sensor, as well as a website instead of a touchscreen to display a result. And this is a visual description of our system. As you can see, the sensors are still on the bottom left, as well as our database and web page display on the top right. And yeah.
So now talking a little bit about our related theory and what we use in terms of finding that stress level or that anger level that our clientele will be reaching. We focused on using the pulse sensor and the GSR sensor in order to measure a person's BPM, beats per minute, and skin resistance to see what is that threshold level that they're going to reach as a physical input in order to send signals to our outputs. Two other sensors that we use were temperature sensor and muscle sensor. The muscle sensor being a new feature that we added due to the situation at hand to make our device a little bit more complex in order to get more physical input, in order to really find out what is that physical threshold in terms of reaching that stress level and anger level that they're going to reach in order that we can send in outputs. They're using the temperature sensor, we're measuring that degree, that difference in degree, and muscle sensor in order to feel that tension within the contraction of their muscles to really get an understanding of what it really means to reach a certain stress level.
Moving on to the hardware design, you can see in front of you a small schematic of our device. We have these sensors which are connected to voltage source B. Voltage source B is 5 volts coming from our microcontroller, and the resistors are 10K, so how it regulates the current going into the sensors. Our power source going into the microcontroller is a 9-volt battery, which is standard for the kit that we got. And the outputs connected to it are a vibrating motor and a speaker. Onto our iterations. We have nothing is very simple in life, and our iterations is proof of that. There are small quality of life changes that we needed to do, and such as we needed a more precise pulse sensor, we needed a new temperature sensor, because the ones we originally went with didn't work like we wanted to. They weren't precise enough, or they just changed based off every little thing. For when the situation broke out, we added a muscle sensor, and sadly, we didn't have the time to buy it due to everything going on. We have also changed our algorithm so how it is accustomed to the person wearing it instead, as well as a set base of average values, but it will be a custom after a small setup. And we optimize the code to provide the least amount of delay to make sure that the user isn't waiting forever. Now, below is a schematic. It is essentially the code for the sensors in a hardware schematic form, and it is saying that all sensors need to go off in order for the outputs to go off, in order for the outputs to start working.
We now proceed to the software design. As you can see, this is very straightforward. We simply have the Arduino microcontroller sensors send data to a database via a XAMPP online server. This server allows us to actually broadcast 3 different main files, which are migration.php, password reset.php, and view results.php, which you will see later on as we proceed. Now, in regards to our iterations, well, as I just referred to, we utilized XAMPP online server initially, but then after we separated and came our own ways, I decided to rent a domain here in Bolivia to broadcast our web page via online web so anyone can access it. We utilize PHP MyAdmin as our main database, and this is a co-op database since it's a rented database as well. I implemented PHP and SQL as the main programming languages for our web framework, and this allowed us to receive sensor values from the hardware team via Excel sheets, and through SQL query, we were able to upload those tables to our database and display them in the web page, where you can see many applications.
Talking a little bit in terms of our testing, one of our earlier tests that we did was working with the GSR sensor, a particular sensor working in measuring the skin resistance of a person. We did these individual tests for each of the sensors in order to make sure there was no burn-up or malfunction connected to our microcontroller, and making sure that there was no major errors in terms of how we were getting the information and then using that information to get to our outputs. For the GSR in particular, we did have a few slight problems with the GSR and the pulse sensor, but we managed to fix those problems within the way.
Moving on to our integration tests. Once all our sensors have been gone through their testing and they work separately, we put them all together to make sure that they work, and we had to make sure everything worked the same way. They had to make sure nothing malfunctioned, there was no errors in the code, and that it was able to accurately read all values for each and every sensor. The hardest part to check was the making sure that when thresholds are reached, that the outputs would go off, or that we would even get a notification saying, "Hey, you're not doing well."
One of our earlier modules that we were using was our our audio output module. Now we did several tests on it or audio files, just actually our user when we use the device. As we due to the situation, and switch from this sort of model in terms of using more music, YouTube music playlists, as you'll see later on, in order to designate what kind of mood our clientele or our user is being in, and then they can get that sort of playlist in order to affect, in order to calm them down based on their mood set.
Design of this project. For example, our pulse test had many because we had to make sure that it was accurate, one of our most important parts. And also we took a couple tries to link the database to the server, but eventually we were successful in that. And yeah.
So there's two main areas that we have to consider upon project completion. First, the future work that we plan to implement. We plan to make a prototype of our device since we were not able to once the hardware and software team went their own ways. And as well as we plan to test the sensors further to be able to obtain values that are as accurate as possible in order to better improve our algorithm to produce better results with our applications. Also, we have learned a lot of things from this project. We have learned different programming languages such as SQL, HTML, and database management too in PHP-MyAdmin. The hardware team has learned how to manipulate sensors a lot better in regards to how to implement those with a microcontroller.
As you can see here, we have demonstrated our hardware demo, and within the demo itself, you could see that when Wade tensed up his hand and showed signs of anger, he set off the vibrating motor, which is our first notification telling you, hey, you are getting up there. I think it's time to calm down. After a few seconds, sadly, were not able to hook up the audio, the audio at the moment. We it would be the second line saying, hey, we should try to calm down.
Now we proceed to our software demo. As you can see, the beautiful interface of our main portal has a login and register option. In the login option, well, you could log in your new credentials for a new account, as well as you fill in your age, your height, your weight, and your gender, which you can leave blank too if you desire. And you send those survey results, and they're stored in our database, which we control later on, and which you'll be able to see once you log in to your new account or your old account. As you can see, I already have an account, so I just saved my password and logged in directly. This will take me to the main page of our Bliss portal. As you can see, it initializes with the window displaying our mission and stating what our main objective is with the completion of this project. We also have a window displaying the 4 different team members, and you can view each profile independently. We also acknowledge Manhattan College and the faculty of the EEC department for giving us the opportunity to research for this project. Now, when we go to see my results, you can see the initial inputs you stated in your survey. Additionally, you can see the thresholds for each sensor there. And then you can generate sample data. How we did this? Well, we initially tested the sensors with our team members, and we found a pattern, a recurring pattern. Using this pattern, we were able to determine what values were realistic for people, everyday users. Based on that, we developed threshold values. If you surpass those threshold values, well, you'll get a view notification where you can either be feeling stressed, depressed, or anxious. and narrowing it down to whatever you feel like. You can select each one, and you'll receive a playlist of music to calm you down, as well as a series of recommended actions, which you can see right here, if you're not feeling better. If you are feeling better, you simply click yes, as you'll see right now, what I'm about to do. Proceed to recommended actions, and if you feel better after that, well, it'll take you back to the main portal, because there's no need.
Moving on to our cost of the device, our cost has been inflated slightly due to the buying of multiple components and needing to fix some of them. Of course, this affects our research costs, so our research total comes out to about $138, but taking away all of that costs, just gonna make mass produce this, it will come out to about $95 in total to create one of these.
So some standards that we were concerned with were the SQA and STD, software quality assurance, IEEE 730, and software test documentation, IEEE 829. And the reason we were concerned with this is because of how many software files that we have, and we need to make sure that they work properly. Everything. And as far as ethical codes go, on the right, we're concerned with making honest and realistic claims according to IEEE, and we also will not disclose private information without consent. And to do this, we have accurate and frequently tested sensors, as well as a secure MySQL database for information. And are there any questions?
Yes, I have a question, okay?
Sure,
What IEEE standards did you use to your work? IEEE standards.
We just researched some that we might be concerned with regarding our project. So we just found some that we might be concerned with. We didn't necessarily like create them or anything, but
You have to write few words about the IEEE standards or any professional standards in your project. Now, write down, Dr. Wang, this is important for their grade. Write down, please, standards, use, professional standards, IEEE standards. This is very important. Second question now. Second question. I don't see any timeline about your project. Do you have any diagram that shows the workflow?
When we look at the guidelines for the project, it did not require a timeline this time compared to the
It
other
requires,
ones.
yes, it's a mess. This is
Yes, we didn't
negligence.
have a timeline.
It's very important to have a timeline. They want to see in EBIT that you are able to plan, to make planning. So include a timeline on all your projects, please. Budget cost. Do you have budget cost? Cost of the budget, how much cost? Okay, write down, please, everybody. Yes, very good. Write down, please, timeline. Make a timeline with your diagrams, with a flow chart, indicating how you progress from one stage to another. This is very important. Number two, for everybody, write down the IEEE and professional standards you use. Otherwise, if you don't write this, your grade will be affected, I'm telling you. Dr. Wang and Dr. Sultan, this is very important things to be documented.
Professor, if you allow me to interrupt you, we utilized IEEE 730 and 829, if that's what you were talking about. One
Exactly.
ensures quality. Yeah. One ensures quality. That's in our PowerPoint. I don't know why it
Exactly.
wasn't
Exactly.
mentioned.
But write it
Yeah,
down in your text.
yeah,
Exactly.
they're
Yes.
right there. 730 quality
Excellent.
control.
Excellent. 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 Because I noticed at the beginning you have it, after I didn't see it. So excellent. Timeline. Okay. The planning is very important part. The planning. Do you have any section that says that you did this and the other did that and the other did that? Do you have a session to highlight each one functions?
Well, as we have the IEEE 829, yeah, we did document it, but we don't have it in the presentation.
No, it's okay. This is enough. You can put it also in the reference section. Open a reference section, and you can put it at the end of your document, okay? Once you write the final report. Now, do you have anything, Caesar, what is your work? And Godly, what you did, do you have it under specific page? Who was the project manager? Who was the documentation manager? Who was this? Do you have a special page on it?
Yes,
The beginning
we
should
have
be
that
the beginning.
earlier on when we were introducing
Let's do.
ourselves.
Okay, project. Excellent.
Yeah.
Okay, it's important
What
everybody
we
has
each
this.
did in terms of.
Okay, this is excellent. So you think the timeline, the planning of your work is missing. Write a section, project planning, mention the months, what you did. Okay, 1 to 3rd month, we're going to do the library research, 3 to 5, the ordering components, 5 to 7, design this part, and so on. 1 page, okay, for all the projects. You can use either ways, any type of diagrams to highlight the workflow of your project. This is very important for every team, for each team. Thank you very much. Thank you. Very good job. Otherwise, I found that the work is innovative. Another question, Caesar, because I know you, do you show how you interface your work with other disciplines, with other teams that is multidisciplinary?
The project overall, you mean?
Yes. You have to dedicate few lines or a session, like you say, the impact, etc. You say our team is multidisciplinary, involves computer engineers, electrical engineers, knowledge of psychology, whatever you say, knowledge of computer science. You have to put it to indicate the multifaceted nature of your project. Is it fine, guys?
Yeah, we even including in our preliminary presentation, we talked about how this has multiple applications. There's research that has to go.
Applications is different. Applications is different. It is different to highlight the multidisciplinarity of the project itself and the complexity. Complexity means not that you did something very difficult, but you engage several forces. Listen, students, this is for every group. Important, you write, you open a session and you say complexity of project, and you mention inside multidisciplinary teams. You mention knowledge you use from different disciplines, from physics, for engineering, for science, for psychology. Please do these 2 things that are missing: the complexity of the project, 1 session, and the timeline, the project planning, which is very important, another session. The project planning will precede everything. Okay, guys? Otherwise, This is a nice project. It has all these components, it's innovative, and I applaud your work. Okay, thank you very much.
If you excuse me, also you could check the webpage if you'd like with a link that I'm sending the message. If you just want to check it out of curiosity.
Okay. Please
thank
try
you,
to
everyone.
add
Next
these
one.
functions for all the projects. Thank you, Dr. Wang. You can now direct the projects. Thank you.
Thank you, Dr. Gackles. Any other
Yes,
questions
please
that you
try
have?
to.
Shall I take that as no other questions?
Yeah, this is Bill Zucker. I just want to say good job, and I want to ask you one more question. Then, what was the most difficult challenge that you had working together as a foursome in resolving any issues that popped up, and how did you resolve it?
So some of the bigger challenges that we've had was, first off, deciding what to do, because we sat down on the first week that we were a group and we all said we're not leaving until we come up with a project that we all want to get behind, because I don't want morale to be low or anyone to do what they don't want to do. So that was one of the bigger challenges. As for actually doing the actual building of the device, one of the bigger problems I've noticed was that I already saw ahead of time was the inputs, trying to figure out what to do for an input to make it portable, to make it so how it can work in about everyday environment. And the one that we went with, the sensors that we went with, not only worked with our microcontroller that we chose, it was also very easy to make it into a more compact device and for it to work as needed. Of course, due to the virus going on, we didn't have access to all the tools necessary to make it into said device. So we had to finesse with the inputs a little bit. But if later on, if we were to continue working on this, then we would go on to creating it into our small device that we have originally planned out.
Okay, thank you very much.
Doctor,
At what point did the
Mr.
project separate?
Okay, at this point, sorry for my interference, but Mr. Zucker make a very nice observation. You may want to include in your project technical challenges. Write down, please, technical challenges and how you address these technical challenges. A small paragraph, a small session. Okay, guys? So technical challenges, project timeline, and whatever we say, has to be written inside your project. Thank you. Thank you.
Okay, thank you, everyone. Yeah. So, so next presentation, let's welcome Dr. Ilmanai to introduce her teams.